This video is sponsored by brilliant.org.
I was originally going to make this video about controlling Philips Hue lights because that's kind of fun, but I've just been in Manchester Pride and now I'm back at my parents' house for a week to relax and recover a bit, which means I don't have any Philips Hue lights with me, so it would be a pretty awkward video to make. So instead, I'm going to talk about the slightly less colourful topic of config. Each service in this home automation system needs various bits of config. Now that might be flags to enable or disable particular features, ports to use, URLs to connect to, usernames, etc. And it's often stuff which is different in development versus in production, so you wouldn't want to just hard code the values and commit them to Git. So far each service that I've worked on, they haven't all made it into videos yet, but each one just manages its own configuration. So it reads from a file, has a way to do that, it reads it into some kind of data structure in memory. Frameworks often have a feature for this built in, and it hasn't been too bad, but I feel like I'm reinventing the wheel a bit with each service, and since I'm basically writing each service in a different language, the way configuration is managed varies quite a bit between them. So sometimes it's in a Python file, sometimes JSON, sometimes YAML. Some of it's in environment variables. Sometimes I've got config just hard-coded in the code with an if statement to see which environment it's in. And I'd like it all to be a bit more consistent. And it would also be nice to manage config centrally, particularly because a lot of services share the same config. Some common things are shared between pretty much every service. For example, the Redis host and port. What the config is exactly is not too important yet. I just want to build a way to manage config. And since I'm building everything as a microservice, building a config service seems like the way to go. An alternative would probably be to use environment variables for all of this. I could put environment variables in the Docker Compose file in development, but trying to distribute them to production when I've got some services running on a variety of Raspberry Pis and maybe others on a server becomes a little bit more disjointed, I think. And I would like to maintain that central place for configuration in production as well. So the requirements for this service are to support reading config from a file. I think that's still a really easy way to define config. I don't have to mess around with making HTTP requests to this service to define the config in the first place. I just want to type it out in a file. Specifically a YAML file. So I could do it in JSON. It's ultimately going to go over a JSON API, but I just prefer YAML syntax. It's easier to write and read. So I'm going to aim for that. Like I said, a lot of services share the same base configuration, so I want some way to define base configuration that every service gets, and then service-specific config, which is laid on top of that. It then needs a way to return a particular service's config, including the base config, over a JSON endpoint. A bonus feature would be to automatically reload the config every 30 seconds or so. So if I go and change the file where the config lives, I don't have to restart the service for it to update. I think that covers everything this service needs to do. It should be pretty simple. So I'm going to write it in Go, which is a really simple, lightweight language. I think it's quite well suited to this task. So let's get started. Or should I say let's go? No, I shouldn't say that. The first file you need in a Go project is a file called main.go. This is where the main function lives, it's where the program starts, but I'm not going to put anything in here yet. There's nothing useful I could write. What I'm going to start with is a package called domain. I'm going to make a file inside here called config.go. The domain package holds the types, or in this case the single type, the config type. So I'm going to make this type as a struct which is exported. And it's just going to be an abstraction that sits over the top of the underlying config data structure, which is just going to be a map from string to interface. So it's a map where the keys are strings, but the values can be anything because every type implements the empty interface. So this lets us have values that are integers, strings, or more maps to create the nested structure. So this supports anything that JSON does, basically. So one important function that this needs is a get function. So it's going to take a service name as a string, and it's going to return that service's config, which is going to be a map from string to interface, and also potentially an error. So I'll come back to that in a few minutes. The other function that I want here is a function that will take the raw data from a YAML file, which would be an array of, or a slice of bytes, and then set the config based on that. I don't have the best name for this, but maybe just like set from bytes. So there's no implementation yet, but that's essentially what the config domain object should look like, I think. So it's abstracted slightly from the config file on disk, like the YAML file that I'm reading from. It's just passed in the results of reading from that. It's coupled slightly because it's going to do the decoding of that file, but I think that's fine. It has to sit somewhere. And then has a get method which will return the config for a specific service. So back in the main function, we can now add our first line. We can create a config struct. The imports are going to get a bit ugly here. I think that'll work. I'm writing this directly into the tutorials repo, which I'll push after I've recorded this video, and then you can see the source code exactly as I've written it in this video on GitHub. And I'll separately add all of the code to my actual home automation repository. Okay, so we've got this config object. It's just empty at the minute, it doesn't do anything. I'm going to take this chance to switch to VS Code because it'll make my life a bit simpler when I'm trying to deal with the imports. Okay, so the next thing we want to do is actually read something from a file. Let's just call this /config.yaml for now. I'll figure out what this path should be later. We can just panic if there's an error anywhere for now, and do config.set from bytes. So just to make this compile, let's return nothing from these functions. It's complaining at me because I don't have comments. Okay, so the code runs, it complains that config.yaml doesn't exist. Let's maybe create a file called config.yaml. Okay, now it runs, there are no errors. It's reading config.yaml and it's colon set from bytes, but it doesn't do anything. Let's add some more interesting logic. So set from bytes, we first want to unmarshal the YAML. So there's a YAML package, this one here, which I'm going to use. And I just pass it the data and then pass in the struct that I want to unmarshal into. Now typically you'd know the structure of your data and you'd create a struct in Go to match, but I don't, so I'm just going to unmarshal it into an empty interface, and if it works the same way as the JSON parser in Go, then it'll work and I'll get a map of string to interface. With some luck, I'm just able to directly set the config like this. Oh, no, I can't do that. Okay, that makes sense. I've got an interface type. I'm trying to set a map string to interface. What I can perhaps do is take this interface and assert that it is a map of string to interface, because I would expect it to be. If not, then we can return an error. Compile time, nothing is wrong here. We'll find out at runtime whether raw config actually is a map of string to interface. No, it's not. Alright, let's find out what type raw config is. If we just print %t and pass in raw config, it should print out the type, which it thinks is nil. Maybe that's because our YAML file is actually empty. Let's add some config. As we discussed before, I want some like base config which everything would share, so things that are common between all of the services are the API gateway. In dev, it's really easy because Docker does the host names and they just match the service names. Similarly, Redis is used by a lot of services, and then we'll have service specific config which is laid on top. So the config that the device registry service has is the path to the device's file, the database file that it uses to save state to. Okay, that works. Now it unmarshals it and it's a map from interface to interface. Okay, that makes a lot of sense actually, because YAML, being a superset of JSON, supports keys that are not strings, as in anything can be a key. So to support that in Go, it comes out as a map of anything to anything. Now I'm wondering whether using YAML was a mistake. But let's keep going with this. I prefer YAML, it's a nicer format to read and type in. we just need to make sure we don't do anything in YAML that is not supported by JSON, because ultimately this has to go over a JSON API. We could do it as like a string inside JSON and then at the other end unmarshal it again, but that seems like unnecessary effort for every service to do. But okay, we've got an interface here. Let's call this untyped config. That's not really true. It is typed. It has a type. Everything has a type, just not the type we want. What we need to do is essentially just iterate through this map and convert all of the keys to strings. Or not even convert, just assert that they are strings, because assuming we only ever use strings as the keys, so the keys would be like base, API gateway, Redis, etc. As long as we only use strings, they'll only ever be strings. So I think we can write a function to do this. So let's take our map of interface to interface and return a map of string to interface, and also potentially an error if something here goes wrong. So let's first make the map that we want. So we've got m the original one, n the new one. Let's iterate through all the keys and values in m the original that we get in the argument, and just assert that the key is actually a string, and if it's not, return an error. We could just cast it to a string and avoid the error situation, just force everything to be a string, but if we're getting keys that aren't actually strings, it probably means there's a mistake in the config, so we'd want to know about it. So we're just going to assert that they're strings and then let it error if it's not actually. If you see the difference, here we're just going to say go this is a string, and go will either say yes you're right, or hang on no it's not, something's gone wrong. The alternative would be to convert to a string, so if it's the number 10 it becomes a string of the characters 1, 0. The next bit's a bit trickier. We need to think about the values. So we're going to iterate through this map and we're going to get the key and value. The first thing we'll get is the key of base and a value of this itself map. And the keys within this map we need to convert to strings, so we need this to be recursive. So we need to know if v, the value, is actually a map. So we can just assert that the value is a map, the same as what we've done here with the key. We assert that it's a string, and the second parameter we get back is a boolean to say whether it actually was or not. So value as a map, just assert that it's a map from interface to interface, and if that comes out as okay, if it actually was a map, then we do some other stuff. Specifically, we make the recursive call, so set v to be equal to convert keys to strings, vmap. Check for the error, and then at the end add to the new map, use the new key now that it's definitely a string, and v, which may or may not have been recursively put through this function. So now, after this for loop, we can return n, which is hopefully a map of strings to interfaces. So now, we've got our config of a type we don't want. We can convert it to the type that we do want. Oh, I'm glad it just spotted this mistake. So it says v declared and not used. This is because I'm declaring v as a new variable using colon equals, which means it's not overwriting this parent value. I need to use just a single equals on its own. But then of course it complains that error is not a variable that it knows about. Error is now undefined. So we need to define error, then that'll work. Slightly ugly thing that sometimes happens in Go. So now using a single equals v will overwrite the one that we want. Cool, no errors. Everything looks like it's working, but of course it's hard to test because we don't have this get implementation yet. So this, of course, is the next one to write. Let's first get the base configuration out, so we can just read from the map like normal. And we'd actually expect this to also be a map. If it's not a map, then something's weird. As in, if this wasn't a map and it was just a string, that doesn't really make sense. It needs to be a map. So let's assert that it's a map of string to interface. If that assertion failed, then return an error. Next, we want to get the config for the service specifically, but we don't necessarily know whether this is set. So what we can do is ignore the value for now and just see if it exists there. And if it doesn't, then just return the base config. We don't necessarily have to define config for every service. It can just return the base config if there's nothing specific set. So that bit's really easy, that's done. Otherwise, if we haven't returned, it means there is some specific config for this service. So again, we can assert that this is a map of string to interface. If it's not, really tedious, return an error. Now we need to merge these two maps into one. If a value exists in both maps, in A and B, in the base config and in the service config, then the service config should take priority. So let's make the map that we want. Iterate over the first map and just set the value in the new one. And then just do exactly the same for the second map, and it'll add new keys that didn't exist in the base config, and it'll overwrite keys from the base config that did exist there. Whoops, that should be a V. So in Go, there are no functions built in to merge maps and do things like this for you, but it's super simple just to write it out yourself. That took like 30 seconds. So now we can return the config and nil for the error. Cool, as long as I haven't made any typos, that should work. And we can test this out in the main function. Because now we can do config get. Let's try to get the base config. That should actually pick out the base config twice and merge it together, but you just end up with the same thing again. Okay, not a very pretty way to print it out. But we do have that map there. So that's cool. And the nil at the end is the error. I should have actually done like that and handled it separately, but whatever, this works. If we pick a service that doesn't exist, then we get just the base config again. One interesting thing to note is that the order of keys in maps in Go is not deterministic, so you can see port and host come out opposite ways around, and you never know what it's going to be. It doesn't matter for us though. And let's just test that we can actually override something here. So if we set the API gateway to be something new for service.registry.device and then try to get the config for that service. The Redis, now that comes out first, is still correct. We've got the database and we have the API gateway, which is something new. Perfect. This looks like it worked really well. We've managed to stick with YAML despite this bit of complexity here, but not to worry, it works. So now we need to turn this into an actual server so we can make HTTP requests to do it, to get this information. I'm going to make a new package called controller. And this is going to have a handler in it for the endpoint to get config. I'm going to do this as a struct. It's potentially a bit over-engineered and it could just be a function. But I think it's nice to be able to pass in dependencies to a struct. So specifically we need the config to be passed in. We need like this singleton config object to be passed around. The one that we've loaded the config into. So we'll add a function to the controller which will be called readConfig. So it takes the response writer and the request. This conforms to the standard HTTP package interfaces. And I'm going to use Gorilla Mux as the router. It makes life very easy. We can pull out parameters that are in the URL with mux.vars. VS Code is nicely handling all of the imports for me here. So the service name is, so vars comes out as a map, so we can just look for this item in the map. If for whatever reason it's not in the map, then we want to return an error in the response. So we need to do a couple of things. We need to set some headers, specifically the content type header on the response writer. Then we can write a status code. Bad request status code is probably fine, whatever number that actually is. And I don't know if there's a more conventional idiomatic way to do this, but we can print to the writer. We should print some JSON here, like a string representation of some JSON. I leave that as an exercise for you to do. Instead we'll just write error. That's fine, we should never actually hit this case. We can then do c.config.get on this service name. Remember, this can actually return an error, so we're going to do the same thing again. except this time we probably want internal server error as the status. Finally, we can create our response by doing json.marshal, pass in the config, which is a map. Again, if anything with that goes wrong, just write out error. Again, this should be not a string, this should be JSON with the error encoded inside of it. Finally, we can write a success status code and the response as a string. So that should just about work. In our main.go file, we can connect all of this up a bit more. So we create the config object, read from YAML, set the config from the resulting slice of bytes. Now we want to create one of these controllers and pass in the config to it. I'm going to use a package that I wrote, which is actually just a really simple wrapper around a couple of other common packages in Go for creating an HTTP router with middleware, specifically Gorilla Mux and Negroni. But it makes it super simple just to do new router, then router.get to add a handler for a GET request. So we can have this URL parameter called service name. The handler is the read config function that we just wrote. So if we delete this bit at the end and instead do listen and serve port 80 and see what happens. So in this tab, I should be able to run it. Okay, add in log.fatal gives me the error here. And let's run it on a different port. Okay, so that's running. In another tab, I'm going to use the httpy util to make some requests to it. Amazing, it returns JSON with our config in. If we do the same for the device registry, then we get the overridden something new. We get the Redis still and we get the database. Perfect. So this is an essentially completed config service. The bonus part was to automatically reload config. I think we can do that quite easily. To reload config automatically, I'm going to create a new package called service. I don't have a better name for this, like something which just sits in the background and runs all the time like a worker. I'm going to create, for want of a better name, a config service. This again is going to take a pointer to the config struct. It's important that it's a pointer everywhere so that we maintain this singleton and don't duplicate it. And let's also take a location. So that's the location to the file. And we can add a watch function. So if we take a duration, this is essentially just a for loop. And it's at the end going to sleep for the duration d, and before that it's going to reload. So let's pretend there's a function on this service called reload. If any errors happen, we can just log them. And that's as simple as the watch service needs to be. When time.sleep is called, it'll just disappear into the background and the other Go routines will run. So this infinite for loop, which is essentially a while loop, won't hog the CPU time. It's only going to use CPU time every 30 seconds or whatever we set the duration to be. So let's write that reload function which we've called, which doesn't exist yet. We can now move some of the stuff from our main function into this, essentially just that bit. And instead of config.yaml, we can read from s.location. And if there's an error, then we just return the error up the chain, and it's going to get logged here. s.config.setFromBytes. So this is pretty simple. In the main file now, we create a config service instead. Give it a pointer to the config and also the location of the file. We can then, in a Go routine, call config service.watch. And let's reload config every 3 seconds. I think in real life that would be more like 30 or a minute, but we want to be able to see the changes quite quickly. One more thing that I'm aware that we need to do. We now potentially have concurrent access to the map, which is in the config struct, this map here. We could have a request that reads from the map at the same time that this second Go routine is reloading the config from the YAML file and writing to the map. Now maps in Go aren't thread safe, they don't support concurrent access like this. Two Go routines can read from them at the same time, but you can't have two write and you can't have one write and one read. So we could get in a situation here where our program panics. We could solve this with channels. Channels are usually the solution in Go to concurrency problems like this, but in my head it's a bit messy to add channels to this particular bit of code, and I think it's potentially more straightforward just to use a lock. So we can use the sync package for this. Just like the config map, this doesn't need to be exported. Nothing else in the program needs to care that we're taking a lock inside this config struct. It's nicely abstracted away. So all we'd need to do before we write to the config object down here is take a lock, and then we can do defer unlock. So that means when the function's finished, whether it panics or whatever happens, it'll release the lock again. But not until we've written to it. So when this line happens, when we're writing to the map, we've got a lock on the map. Remember, there's only one instance of this config struct. It's a singleton. We're passing pointers around everywhere, so nothing else is going to be able to access the map at the same time. Certainly not through this method. The other method, of course, is the get method. Here we read from it immediately, so we want to take a lock straight away. We can take specifically an R lock, and this will allow two things to read at the same time, because that's okay. And again, defer unlock. And I think that's all we need to do. So if I run it now, it's running again. I can read the base config, and if I then update the config, so if I wanted to add a new key, I don't know what it would be, but something new to the config, without restarting the Go program, if we read it again, we now have that new key, new value. So every 3 seconds it's reloading the config, and again if I delete it, then it's, oh, I haven't waited long enough. There we go, it's gone again. As soon as the config's reloaded, that Go routine is sitting in the background, just reading from disk every 3 seconds. Like I said, we'd probably want to reduce that to 30 seconds, a bit more reasonable. But that's really cool. We have this concurrent Go routine. It's safe, it's not going to panic because of two things writing to the map at the same time. And we've implemented all of the features that we wanted from this config service. I hope you managed to follow along with that and found it either vaguely interesting or useful. I'm quite pleased. I've got a working config service. I'll integrate it with the other services later. Like I said earlier, the code that I'm actually using, the up-to-date version for my home automation system, is in the home automation repo on GitHub. I'll put the link in the description. The code that I wrote in this video will be in the tutorials repo, so head there if you want to take a look at the code in any more detail. Maybe you want to spend more time looking at the algorithm we wrote to recursively iterate over the map and assert that all of the keys are strings. And if you find this kind of thing interesting, you might want to learn more about computer science. If you do, take a look at Brilliant, a problem-solving website that teaches you to think like a computer scientist. Instead of passively listening to lectures or videos, you get to master concepts by solving fun and challenging problems, and Brilliant provides the tools and framework you need to tackle these challenges. Brilliant's content is based around breaking up complex topics into bite-sized chunks, and they've got whole courses built around topics like logic, algorithms, machine learning, and artificial intelligence. Sign up for free at brilliant.org/jakewright. The first 200 people to use that link will get 20% off the premium subscription. Check it out, let me know what you think. Also, let me know what you think of this series so far. Leave a comment, subscribe if you haven't already, and I'll see you next time, hopefully when I'm back in London and we can talk about hue lights. Thanks for watching.